Okay, so you've watched the intro to sequences and series, and what we're going to look at today is arithmetic. There's this button on this pen that makes the page go up and down. It's really quite irritating. I should disable the button so it doesn't do that. So what we're going to look at is arithmetic sequences. Okay. And so you remember that an arithmetic sequence is just a sequence where the numbers go up by adding or subtracting the same number every time. So 6, 8, 10, 12, 14, etc. Okay, that is an arithmetic sequence because it's going up, it's adding to every time. Beautiful. I'll prove this in class, or you may have seen it already, but what we're going to say is remember that an arithmetic sequence is defined by, you get the previous number, previous term, so Tn, you take the previous term, Tn minus 1, and you add a certain difference. So D is the difference between, in this case over here, the difference would be 2, positive 2. So I've got that. That's just the definition of a sequence, arithmetic sequence. The first term we always call A. Okay, so that's just our first term there, and I'm not going to show this in this video, but I'll happily show it to you in class. But a way to actually write Tn that doesn't involve the previous term is like this. It'll be A plus n minus 1 times D. Now these are the sort of important pieces to the puzzle that you should really have at hand for your test or whatever. And in particular, these two. In the previous video I talked about defining it in terms of the previous term and then defining it in terms of n. So this one is much more powerful. That's the one we really want to know. And if you're trying to change from this type of definition where it's defined in terms of the one before it, this is the good way. This is how you change it in terms of n, and this is much more powerful, much better down here. And basically that's all there is to arithmetic sequences. This is all you need to know. Let's have a look at an example. Let's see if I can squeeze it in down here so that we've got our formulas up here. Okay, so find the 12th term. Find the 12th term of, let's go 63, 52, 41, etc., etc. Okay, great, let's have a look at it. What do we know? Okay, well, we know the first term. What's the first term? A is equal to 63. Perfect. What's the difference here? What's happening? It's going down by 11. Okay, whoops, so 11, it's actually going down, so it's negative 11, going down by 11 at each time. So D is equal to negative 11. What's n equal to? Well, we want the 12th term, so n will be equal to 12. Perfect. So finding the 12th term. Now let's have a look at this. Let's have it. We'll always be using this formula, to be honest. It's much more powerful, much easier to use. So what we want to find is we want to find the 12th term. T12. What is that equal to? Well, I won't write the formula because I'm going to run out of space otherwise. But A, which is 63, plus n minus 1, so that'll be 12 minus 1. Times D, so times negative 11, and we just figure that out. Okay, so that's 63 plus, that'll be 11 times negative 11, so that'll be negative 121. Whoa, what's wrong with me? 121. Just make sure 11 times negative 11, 121. Okay, 63 minus 121. Do I really have to do this in my head? That'll be 121 minus 63 is 118 minus 60 will be negative 58. Please excuse me if I got that wrong. I could check it on the calculator. Should I do that? I better. Just to make sure. So calculator 63. Good, negative 58. Wouldn't want to get that wrong. Thank you. That's the end of arithmetic sequences and how to find certain terms given a sequence. There you go. See you in the next video.